Okay, one more little video, and this should finish the last stuff on that last sheet. Okay, so after internal resistance of a power supply, you'll see you have notes on meters in a circuit. And remember the other day we talked about the fact that there were two meters. One is a voltmeter, and voltmeters are used to measure the voltage across different things in a circuit. So you could find the voltage across R1, known as V1, the voltage across R2, known as V2. You could find the voltage of the whole circuit, okay? And so that's with a voltmeter. And then the other meter that we know about is an ammeter. And an ammeter is used to measure the current flowing in a circuit. Okay, and so you could use it to find the current flowing through R1, the current flowing through R2, etc. So I'm going to draw two circuits here. I'm going to draw a series one. I'm just going to put two resistors in it for the sake of time. And I'm going to draw a parallel one. Okay, and assuming that you've done your series and parallel questions, and these guys should look pretty familiar to you. So this will be R2, this is R1 over here, this is R2, this is R1. And so the question would be, if I want to measure the current first, let's do the ammeter. If I want to measure the current through this R1, where do I need to put the ammeter? Well, if you remember, current is the same when it's in series. So over here, all these I's are the same. And so if I want to find any of the I's, I need to put my ammeter in series. So I could put my ammeter here before R1, or I could put it here in between R1 and R2, or I could put it here after R2. Because the current's all the same, it won't matter. I'm still going to get the same reading here. But the important part is ammeters must go in series with what you're trying to measure the current of. Okay? So if I come over here to the parallel circuit and I want to measure my current in R1, then where do I need to put it? Well, the current is the same when it's in series, so I would need to put it in here. If I put my ammeter here, this will give me I1. If I put my ammeter anywhere up here, anywhere up above the junctions, what should I get? It should give me the current that's flowing through R2. It should give me I2. And if I put it down here below the junction on either side of the battery, then I should be getting I total. Okay? So even though it's a parallel circuit, I still need to put my ammeter in series. I just need to be careful that I put it in series with what I want to measure. So in series with R2 if I want I2, in series with R1 if I want I1, and in series by the battery if I want I total. So that's for ammeters, because remember, in series the currents are the same. So ammeters have to go in series, so I'm getting the correct current. Now how about voltmeter? What if I want to measure the voltage across R1? Well, if you remember from our series and parallel conversation, voltage is the same in parallel. And so that means I'm going to need to put my voltmeter in parallel with the thing I want to measure the voltage across. So if I want to measure V1, I would put my voltmeter connected so it was on either side of R1. Because now this voltmeter is in parallel with R1, and so it's going to give me V1. If I wanted to measure the voltage across R2, then I would put my voltmeter in parallel with R2. And I just drew it down here so it wouldn't be so cluttered up there. Okay, so it's in parallel. Remember, the idea of parallel is when there's a junction and the current has to make a choice. So I can't put my ammeter in parallel because then it would split the current and I would be measuring the current not flowing through R1 or R2. But I have to put my voltmeter in parallel because in parallel things have the same voltage. So by putting my voltmeter in parallel, then the voltage that this is reading is exactly the voltage that the R2 has. Over here it would be exactly the same. If I want V2, then I would hook it up parallel to R2. And if I want V1, then I would hook it up parallel to R1. And if I want V total on either of them, I could put it over the battery in parallel. Okay? So voltmeters must be placed in parallel. Ammeters must be placed in series. Okay? So that's all there is to know about voltmeters and ammeters. There's no equations or anything like that to remember. And on the back of your sheet of notes, I gave you some pictures to show it. Okay? The next thing up is, what if you had multiple power supplies in your circuit? Okay, so what if you had more than one battery? And just like we can have there are two ways that we can hook resistors into a circuit, there are two ways that we can hook power supplies into a circuit. One way is in series, and the other way is in parallel. So first in series. Let's suppose each of these are 1.5 volts. So I have 3 AA batteries and I hook them into a series into a circuit. This happens all the time. You open up your remote control, you probably have your TV, you probably have either 3 or 4 AA batteries in there. Okay? What good is it? Well, when you have multiple power supplies in a circuit and they're in series, they just add up to give you an overall total voltage. Okay, so we just add these up and this would have a total voltage of 4.5 volts. So lots of times your circuit needs more voltage than one battery can give you. Now notice they all have to be oriented the same way. And if you've ever put batteries in something and put one in upside down or the wrong way around, you would discover it didn't work. Because if one of these was the wrong way around, it would effectively be taking 1.5 volts out of the circuit. And so you wouldn't end up with the 4.5 volts in this case that you needed. Okay? Now I know sometimes when you put batteries in, they look like they're opposite because one goes like this and the other goes like this. But you have to follow the wires. And if you follow the wires, you would see they're threaded this way, and so they really are oriented the same way. Okay, so when multiple power supplies are in series, they just add together to give you the total voltage. If multiple power supplies are in parallel, it's a little bit different. Okay, because in parallel, remember the current is only going to flow through one of these or the other, not both. So the current will either flow through this battery, go up around and come back, or it'll flow through this one, go up around and come back. So the voltages don't add up here. The current is really only picking up 1.5 volts no matter which route it's traveling. So why would we have multiple power supplies in parallel? Well, it's because they're going to last longer. This will give you longer life. And that might come in handy if it's something like smoke detectors that you don't want the batteries dying right away, or something where it's a really pain in the neck or other anatomy parts to change the batteries. Lots of times kids' toys where the batteries are like buried deep inside and it takes 4 screwdrivers and a hammer to get them out. They'll put the batteries in parallel to give it longer life. Okay, so that's it for multiple power supplies. What do you need to know? If they're in series, they add up. If they're in parallel, they don't add up, but they give you longer life. The last 2 little things are Kirchhoff's rules. Kirchhoff was a German physicist who did a lot of work with circuits. And so his first one is the loop rule. And really, we've been using the loop rule through all of this, because all Kirchhoff's loop rule says is that as you go around a loop in a circuit,